All right, so last thing we'll finish up with this week is looking at why you would write a complex number in polar. And basically, that's the reason why. It gives you a quick way to do multiplication and division. Okay, and what's nice about the method I'm about to show you for multiplying and dividing complex numbers, think about if you wanted to divide two complex numbers. First, you've got to find the conjugate. Then you have to multiply the top and the bottom by it, which involves FOILing, getting some I-squareds, having to combine like terms. Okay, and then you've got to take your final answer and you've got to separate it into a real and imaginary part. And then even worse, if you can reduce the fraction, you've got to do that too. So there's a lot of steps when you multiply and divide the way we learned before. In polar, just about every step I said disappears. Okay, it's a lot easier. So I'm just going to start off by looking at two complex numbers. Okay, I'll call the two complex numbers Z1 and Z2. Okay, so the first complex number, it has a radius and it has an angle. And I'm calling the radius of the first complex number R1. I'm calling the angle of the first complex number theta1. When we do an actual problem, you will be given, just to show you an example, you'll be given something like that. You'll be given a radius, and you'll be given an actual angle. Okay, so you'll have numbers. Okay, so Z1 is R1 cosine theta 1 plus I sine theta 1. And Z2, we'll just call that R2 for the radius and theta 2 for the angle. Again, as I said, when we do an actual problem, R2 will be a number and theta 2 will be a number. Okay, it'll all be numbers. So these are two complex numbers written in polar. So if you want to multiply these two numbers together, okay, Z1 times Z2, if they weren't in polar, you'd be doing everything I just explained. Okay? You'd be FOILing them out. But since they are in polar, you don't have to do that. All you have to do in polar is take the two radii, R1 and R2, multiply them together. Okay? And then take your two angles and add them up. Doing what I'm writing right here takes the place of all the FOILing, all the I-squareds, all that stuff. Just take the two radii and multiply them. Take the two angles and add them. And that's it. Okay? So as long as our numbers aren't too big, we should be able to multiply complex numbers in our head now, as long as they're in polar. Okay, and I called the two complex numbers Z1 and Z2. You can call them anything you want. You can call them Z and W. You can call them X and Y. Just whatever they're called. It's the same process each time. Take the radii and multiply. Take the angles and add. And that's it. So let's see if we can multiply Z times W. Okay. What would my radius be when I multiply Z times W? Any thoughts? Yeah, how did you get 15?
5 times 3.
Yeah, you just multiply the two radii together. 3 times 5. 3 times 5 is 15. And what about my angle when I multiply those together? Yeah, you did?
120.
Yeah, how'd you get 120?
I added them.
Yeah, you just take the first angle, 20, add it to the second angle, and that's it. That's the final answer. Okay, so if you multiply those two complex numbers together in polar, that's what you get. Okay, a lot shorter than the way we learned to multiply complex numbers yesterday. But this depends on having the number in polar. So if you had two complex numbers you had to multiply, and they weren't in polar, well, I'm not sure how much time this would save you. Because first you'd have to change them to polar, and then you could use this trick. All right, let's try this one. This time z is 1/2 cosine 15 plus I sine 15. And w is 10 cosine negative 30 plus I sine negative 30. So when I multiply them together, I have to find my radius, and I have to find my angle. Yeah.
So you don't actually have to solve what's in the middle of the parentheses, you just leave it like right as that, like z times w equals 15 cosine 120 plus I sine 120?
Yes.
Like that's just the answer?
Yep.
Okay.
Because they want you to leave your answer in polar.
Okay.
And that's how it's going to be on the test. If you distributed this 15 out, okay, which you could do, if you did it, you'd be converting it to rectangular. So you'd end up with something like this, if you did it out, which we're not doing. All right, so what's going to be my radius for this one?
5.
Yeah, and how'd you get 5?
Multiply 10 by a half.
Yeah, just take 1/2 times 10. There's my radius. And what about my angle? Yeah.
Negative 15.
Yeah, just take the two angles you have and add them up. 15 plus negative 30 gives me negative 15 degrees. Now, what's something they could ask you to do on this problem that they didn't ask you to do on the last one because it didn't come up? Yeah.
Get rid of the negatives.
Right, they could ask you to get rid of the negatives on the 15. And can you give me one way, Travis, to do that?
Add 360.
Yep. And if you take negative 15 and add 360, what does that give you?
That'll give you 345.
345. Yep. Okay, so that's one way to get rid of your negative. And what's the other way to get rid of your negative that doesn't change the size of your angle? Okay, adding 360 made my angle a lot bigger. How can I do it without doing that? Yeah.
You would just give it the negative in the first one and make minus I sine.
Yeah, with the cosine, you can get rid of the negative. Negative makes no difference on the cosine part. But on the sine part, it does. You can't get rid of it. But you can do what Eden just said. You can move the negative in front. Okay, so minus I sine 15. All three of those answers are correct. It's just a matter of if they ask you to get rid of the negative or not. Okay, so any questions on multiplying two complex numbers in polar? That's the first half of what we're going to look at today. All right, so if we've got a shortcut for multiplying in polar, there's also a shortcut for dividing in polar. Now, if you already have this copied down from the first part, you could just almost draw an arrow because we're using the same thing we started with. Okay, suppose we have two complex numbers again, z1 and z2. This time I'm just going to show you the formula for division. Okay, anyone have a guess what the formula for dividing them is going to be? Based on the formula for multiplying them. Jake.
Exact opposite, dividing the r's and subtracting the angles.
Yeah, this time you're going to divide the radii. Okay, instead of multiplying them, take r1 and divide by r2. And instead of adding the angles, Now you're going to subtract them. And with subtraction, it is important you get the order right. Right? It's the first angle minus the second. So whatever the angle is for the number that's on top minus whatever the angle is for the number that's on the bottom. With addition, it's not as important if you do it in the right order, because think of when you add two numbers. If you mess up the order, you add two things in, that doesn't change your answer. But if you mess up the order you subtract in, that will change your answer. Okay, so any question on that formula? All right, so let's try first example with division. So my two complex numbers are 3 cosine 75, I sine 75, and 5 cosine 30 plus I sine 30. Okay, and I want to divide them. Now, how do I know these are imaginary numbers? What tells me they're imaginary? How about Cody? Tell me, how do I know those are imaginary? Travis?
The I.
Yeah, there's an I. Right? I is an imaginary number. So that's what tells me they're imaginary. Now, normally if I wanted to do division, and I had a problem like this. We're doing the exact same thing, except this is in polar. Before we learned it in rectangular. What would I be doing in rectangular right now if I wanted to solve this problem? Just walk me through kind of the steps I would have to do.
You take the bottom one and make it 8 plus 4i.
Yep, I'd have to take the bottom. I'd have to find the conjugate, which is 8 plus 4i. Okay, and then what would I do?
You FOIL it.
Yeah, I'd have to FOIL everything in the top out. Now we have a shortcut we could use for the bottom. But then after I FOILed it, I'm going to have some like terms I have to combine. I would get an I squared. I got to change that to -1. And when I'm done, I'd have to split it into two fractions and then reduce it. It's not overly hard, but it is pretty time consuming. Okay, it takes a while. This we should be able to do really fast. Okay. When I divide these two numbers, z divided by w, what's my radius? Yep, 3/5. You don't need to change that to a decimal. So it's just 3/5. And what's going to be my angle? Yeah, go ahead, Jim.
Would it be 45?
Yeah, it's going to be 45. And how'd you get that?
I just subtracted the two angles that they give us.
Yeah, subtract 75 minus 30. What we just did there just took the place of everything I explained about division with complex numbers. Okay. Again, you have to have your numbers in polar for this to work. Okay. So if I was going to do this problem, I would probably just do it the way it is, because it's going to take me longer to change the top to polar, change the bottom to polar, and then use the shortcut. Okay. You might as well just do what I showed you yesterday. But if it's already in polar, it does save you a lot of time. Okay, so that's z divided by w. Okay, questions on that? All right, so we'll finish up with this one, make it a little bigger. So z is 10 cosine 20 plus I sine 20. And w is 1/2 cosine 100 plus I sine 100. Okay, so see if you can find z divided by w. All right, so Tyler, can you walk me through just the radius? How do I find it? Yep, can you tell me what divided by what?
10 divided by 1.
Yep, 10 divided by 1/2. And what's 10 divided by 1/2? 10 divided by 2 would give me 5.
Oh.
20, yep. So 10 divided by 1/2 gives me a radius of 20. Okay, and for my angle, Vanessa, can you tell me how to get my angle?
You subtract, you do 20 minus 100.
Yes, and make sure that you did it in the order that you're supposed to, 20 minus 100. And that gives me how much? Yep, negative 80. So if it was a short answer and they didn't ask you to simplify the negative, that's fine. You can leave it just like that. Okay, but let's just write down one of the ways you can simplify it by adding 360. Okay, what would you get for a positive angle if you add 360 to negative 80? Negative 280. Plus I sine 280. Okay, and the other way to do it would be you could just take the negative away from cosine, and for sine, you could move the negative in front. Okay, so any questions on dividing two complex numbers if they are written in polar? Oh. All right, so the homework tonight, it's just 3 questions, 33, 35, and 37. And it's exactly what we just did. Okay, for each problem, they ask you to find the product and quotient. So there's actually 2 parts to each question. Find the product of the 2 numbers they give you and quotient. So you should have six answers on your homework. Okay, so tomorrow we'll have our test on 5.1, A4, and 5.3. That'll be our first test for term 2.